Hi all. Today let's see how we can build a progressive web application using Angular. Progressive web apps or PWAs are basically web applications in their core, but they have additional features like they can be installed in any operating system just like any other program. Using PWAs, we will be able to achieve performance which is similar to the natively installed applications within our systems. Some of the features which are available are offline mode, in which the PWA will be able to execute or operate without any network connection. Another feature is the push notification, which we will be able to do in case of PWAs. The performance of PWAs is comparatively higher since we are caching all the required assets like JavaScript, HTML, CSS, everything is cached within the browser itself. So in order to do this, one of the core feature in PWA is the service worker. Service worker is a worker thread which is used for caching all the assets such as JavaScript, CSS, HTML that are needed by the PWAs in our browser. It also handles the constant checking of any updates available in the server, and in case any new updates are present, downloading them and making it ready for installation in our browser. So the service worker is the most important part of the progressive web app. So here I have created an Angular 13 application, which is a normal web application. Now I have built the application and I have hosted it using the HTTP server. Now this is a familiar application, like it consists of a login page, and once I click submit, it will be navigated to the home page. Now one thing to note is that it is a normal web application, and in case I take the website offline, when I try to refresh the application, you will see that a no internet page is displayed. And similarly, when we try to throttle the network connection, that is, I am emulating the slow 3G, you can see that it takes a bit more time to load all the assets like JS, CSS, and everything, and the rendering will be that much slower. So now let's see how we can convert this same application into a PWA. The first step we need to do in order to convert an Angular application to a PWA is we need to add the PWA dependencies. So for that, Angular CLI provides the command ng add angular/PWA. So once we execute this, it will make the necessary configuration changes within our Angular application as well as add all the required dependencies. So now the packages have been installed, and let's go to the code base and see what are the changes that have been introduced. So first let us go to the angular.json file. So here you can see that in the assets they have added a manifest file, and here they have set the service worker flag as true, which means that this is a service worker and we need to create the service worker configuration for production builds. Similarly, we have the service worker config path where we define the configuration that needs to be used for building the service worker. Similarly, in the test also we have an entry for the manifest file within the assets. Now we go to the service worker config file. This is the main file in which we define the configurations that are needed by the service worker. The main keys that are used within this file are the asset groups. The asset group is a list of assets which we need to cache as part of the service worker, either the installation of the service worker or the updation of the service worker. So here in the assets group, we can define groups of assets and we can tell what is the source or the mode of installation of these assets. So here you can see that the first asset group has a name called app. After that, we are specifying that when this service worker is installed, we need to prefetch, that is, all the resources that we have specified here they need to be fetched before the actual application is bootstrapped. So all these will be eagerly loaded and cached within our browser, and then only our service worker will be started. Similarly, we have another asset group named assets, and here we are saying that in case of the initial installation, these assets need not be downloaded, but only these assets need to be loaded in a lazy manner. That is, whenever a network request is made for this particular asset, at that time we will be caching this asset. The subsequent calls will be handled by the service worker. Similarly, we have the update mode, which says that when the service worker or the application is updated, we need to fetch it in the prefetched manner. And here we have given the list of resources so that we can give in either a files or within a URL. So the URL property can be used for caching assets which can be downloaded from any CDN or similar locations. So here we have provided the assets folder as well as any image or fonts which we need to use in our application. After that, we can go to the package.json file. Here, the service worker library has been added as a dependency. Similarly, in the index.html, the app manifest has been added as a manifest link, and similarly, the theme color has been set. And the app manifest is this file, the manifest.webmanifest. So this file will contain the details of the PWA. So these details are needed when we try to install this PWA into our machines. While installing, all these details will be read, and according to this, PWA will be installed. So here we can give the name of our application. So when we install this PWA, this will be the name of the application which we will see. And in case the name is too long, whatever name we provide in the short name, that will be used for displaying the application name. Similarly, we can set the theme color, the background color of the application, the display. So this is basically the mode in which the application needs to be displayed when the application is open. So either we can give standalone. There are different properties like full screen or minimal. So whatever we choose, based on that, the application will be run. Similarly, we have the scope field, which mentions the views which are allowed to be navigated within the PWA. In case we go out of the scope of this path, what happens is the PWA will revert to its normal browser format, and then it will display the page. So example is like when I try to access an external route like google.com from within our application. So since it is not within our scope, what happens is the PWA reverts back to its browser form, and then it will display the page. Similarly, we have the start URL, which will be the URL, the starting URL of our PWA. So in this case, I have given the root path. And within the icons, we can mention the details of the icons which will be used while installing the PWA application. So we have given different resolution icons based on the devices. The required icon will be used while installing. Similarly, we have all the icons which are created within the assets folder. Within that, a folder called icons, they have added it automatically. And in the app module, the service worker module.register has been added. And this module will basically take care of the registering of the service worker, all the necessary code related to handling of events related to the service worker. All this will be done by this module. Here we need to provide the name of the service worker file as well as some options or configurations based on which the service worker needs to be installed. So here we have given a registration strategy like whenever the app becomes stable or after 30 seconds, whichever comes first, then only register the service worker, because we don't want the actual application to be blocked by the service worker registration. One thing to note while running the PWA is that the PWS can be served only over HTTPS connection. The normal HTTP connection won't be allowed. The only special case in which the HTTP is allowed is the local host, since we need the local host for development. And also another thing is that we will not be able to serve our application using ngserve. We need to build our application and then serve it using any static server like HTTP server. So here I am going to build my application. Our application has been built. Now let us serve this application using HTTP server. So I am using HTTP server -c-1 so that I don't want any caching within the HTTP server. And I am using the port 4200 and I am serving the test PWA sample folder. Now if we go to that particular folder, you can see that some additional files have been generated. One is the app manifest which we saw earlier. Another one is the ngsw JSON, that is the manifest file used by the service worker. And if we open this file, you can see that whatever we gave in the configuration file for the ngsw, those have been compiled and the details have been added here. So previously we had given the regex, those have been resolved and all the files have been added here. Now whenever this particular file gets changed, the service worker will be keeping on polling this file. If it sees that this file has been modified, immediately it will download the latest version from the server and keep everything ready within the browser, but it will not install it. So in case we need to install it, we need to reload the page. Now if we go to our application and refresh it, you can see that the initial calls are all going through the network. But once that has been done, you can see that there are some calls which is showing the gear icon, and it is seen that it is initiated by the service worker. So once this has been done, when we try to reload the application, the next time you can see that it is much faster and the actual network call is not going, but it is coming from the service worker itself. So the service worker basically acts like a proxy which will be in between the network layer and our Angular application. So in case the file is present within the service worker, it will serve from there. Otherwise, it will allow the call to pass through the network and fetch from the actual server. Another thing you can see here is that there is a call to get the ngsw.json with the cache bus as a query parameter. So what it does is like it is trying to check the latest version, fetch the ngsw JSON and checking whether any change has been made to this file after the current build. So in case any latest change has been made, it will try to fetch the latest and install the needed files. In case we are going to the offline mode, now you can see that even in offline mode, our application is working. Similarly, when we try to throttle as well, you can see that our application is extremely fast. Let's see how we can install this application. So here within the browser, you can see that there is an option to install this PWA sample. Now when we click on that, it will ask whether we can install this app, give install. Now you can see that our application or the browser has been replaced by a native looking application, and the application will be installed within our desktop. So this is similar to how we access a normal desktop application, and this PWA will be working as expected. Once we click on the submit, all the images and the home page has been loaded. Now even if we try to stop the server, so here you can see that actually the server has been stopped. Even then when we try to reload, you can see that still our PWA is working fine. So this is one advantage of using the PWA. Now let's explore a bit more into what all things are getting actually cached within the service worker. So here When we go to the application tab, there is a section called service worker where you will be able to see the details of the service worker, and there are many options like we can emulate the offline mode if we select this. Similarly, when we check on this update on reload on each refresh, what will happen is new instance of the service worker is created. And similarly, in case we check this bypass for network, the service worker will not make use of the cache, but will allow all the calls to be made to the actual network. Similarly, we have some other features like push notification. We will be able to send push notification from here. We will take a look at a later stage for that. Similarly, we have the network request. So in case we click on that, we will be able to filter out all the requests that have been passed through the service worker. Similarly, we have options to update the service worker as well as unregister the service worker. Now let's see actually what all files have been cached within the service worker. So for that, we can check the section cache. So we have the cache storage. So once we click on that, you can see different entries, and in this entry we can see all the asset group which we gave as the app name, which consists of the HTML, CSS, JS and all. Similarly, we have another place we have added the lazily loaded thing like images and all those things. You can see that actually there is no APIs that have been cached till now. So now let's see what will happen in case we will enable the offline mode. So when we refresh the application, all the assets have been downloaded, but when I try to click on the submit, you can see that our API is getting failed. So one thing to note is that this particular API, that is a post request. So post request can be never cached by the service worker. The only API calls that can be cached by a service worker is the get or head methods. So in our case, we have a get API that is getting called in the home root. So if you go to the home root, you can see that there is a get API, but even then, since we are in offline mode and we are not caching the API result, the application is failing. Now let's see how we can cache the API data. In order to cache API calls, what we need to do is that within the ngsw config JSON, similar to the assets group, we can add a new key called data groups. This is also an array, and within this we can define the data group. So here the data group name is API, and in the URL section we will be able to give the pattern of URLs which we need to match, and all these URLs will be cached. So one thing to note is that only the get and head methods can be cached. Similarly, we can define the cache configuration, like the maximum size of the cache that can be created. So you cannot add more than 20 entries in this cache. Similarly, we can define the age of the cache and also the network timeout. So in case the network does not respond within 5 seconds, it will make use of the cache. So now here I have rebuilt the application and served it. Now let's refresh the application. So now if you go to the cache, we have all the assets. Similar to that, we have a section for our APIs as well. You can see that API cities is cached here along with all the headers and preview. And these are some meta information. So now let's make this pages offline and try to refresh. You can see that the cities is also getting served from the service worker. Now let's take a look at a service that is SwUpdate that is available within the service worker module. So this SwUpdate service can be used for getting notifications from the service worker whenever a change has been detected, like a new version of our PW has been deployed within the server. This SwUpdate will provide us the notifications. So let's see how we can subscribe to that. So here within the app component, I have injected the SwUpdate and I have created the name as update service. So this consists of a key called isEnabled. So using this key, we will be able to check whether the service worker is supported by the browser. In case it is not enabled, we are logging a console and returning. And in case it is enabled, we are adding some logic to handle the updates which we receive from the service worker. So again, the SwUpdate service has another key, a property called version updates. This is basically an observable, and to this observable we can subscribe and we will get the details of the events. So there can be three type of events. One is the version detected event, other is the version installation failed event, and the version ready event. So this basically means that we saw the ng-sw.json cache busting operation. So whenever a change is detected by the service worker on the server, it will emit the version detected event. And after that, once the new version has been downloaded, it will send the version ready event. So in case any error happens in either of these operations, it will be emitting the version installation failed event. So here we can subscribe for this, and this event can be any of these three. So here I am logging the event and I am adding an alert to show the type of the event. So in case it is a version ready, that is, it has said that the service worker has detected the new version and downloaded it for us, but it has not applied to the actual page. So one advantage of this is that when we open a new page of the service worker and refresh, we will be able to get the latest version. But the currently opened tabs, all those will still have the old version of the application. Once we get the version ready event, we are asking for a confirmation that the new version is available. Do we need to apply that in our browser tab? So in case we confirm it, we will be reloading the browser and the change will be updated. Similarly, we have another key, an observable called unrecoverable. So this basically happens like when the service worker has been corrupted, like the current data or the cache in which we have in the client, it got corrupted and it cannot be recovered by the service worker. In that case, it will go to this unrecoverable state, and the reason for that state also will be available within this observable. So in such cases, what we need to do is we need to refresh our page. Then only the service worker will fetch the latest version and apply it to the browser tab. So now let's build this and see how we will get the latest update. So the application has been built and served. Now let's refresh our application. So if we go to the console, you can see that still the version is not arrived. So let us refresh once more. So now you can see that the console is being displayed and it is showing that the service worker is enabled. But still we did not receive any update because this is the first version where we have actually added the SwUpdate. Now let's do one thing. We can add a small change within the app component HTML and just adding something, some label called test. And now let's rebuild it once more. So now it is updated again. Now let's see whether the actual update is coming to our PWA. So one thing to note is that the actual checking for this new version happens either during the initial phase, like initial loading of the page, or whenever we navigate to a different route. So here you can see that the first check has already completed. Now let's try to navigate to the home page. So still it has not come. Let's do one thing. We will refresh the application. So now you can see that actually the cache bust call has been made and immediately an alert has been displayed like a new version has been detected. And once you press OK, it will say that the version is ready. That means the actual changes have been downloaded to our browser. And now our confirmation screen has come, and it is saying that this version of our application is available, and it is asking whether we should reload the new version. So in case we give OK, so now you can see that even when I refreshed, actually that change is not reflected in our page. So in case I give OK, you can see that the new version of our application has been downloaded and the changes are visible here. So we previously saw how to subscribe to the version updates. And since we are subscribing, we do not have any control over the frequency in which the service worker will be actually checking for the updates. So in case your application is frequently changing and you need to poll the server to receive the new application, the SwUpdate service provides another option. So what we can do is that here we can add a set interval, and within that we can make use of the check for update method. So this is a method within the update service. So using this we will be able to check whether a new version is available in the server for downloading. And in case it is true, we can call another method called the activate update. What it basically does is that it will activate the latest version within our browser, and the changes will be available for us. So now what we have done is we have created a set interval to run it every second, and in case the latest update is downloaded, we will be clearing the interval. So I have built and run the application. So now you can see that each time it is saying like there is no update now, no new update now, and it will be keeping on displaying it. Now what we can do is we will remove the test label which we added earlier, and we will rebuild our application. So our application is built and served. Now if we go here and press OK, you can see that the actual return from the check for updates has changed, and it is saying that it is true that a new version is available for downloading. And once we click OK, you can see that our activate update command has been completed with true, which means that our latest version is going to be applied. So once we click OK, now the latest version is available. Now in case we refresh, you can see that the latest version is activated and our change is available. So this is needed to be done only in special cases in which your application changes very frequently. Now let's take a look at another service that is provided in the service worker module. So that is the SwPush. So SwPush can be basically used for subscribing to any push notifications that we receive from the server, and these notifications we will be able to send to the user using the notification API. This service, if you go inside, it consists of a property called messages, which will basically contain the messages which we receive from the server. And we have another key called notification clicks. So this is another observable which will receive the details whenever the user clicks on any of the notifications which he views. Similarly, he can also subscribe to the currently active push subscription. So basically, again here we will be able to receive the messages. And again we have the is enabled, which will check whether the service worker is enabled, similar to our SwUpdate. So let's go through each one of these. So here again, similar to our SwUpdate, once we check that the service worker is enabled, we will add a new method called handle notification. Push service has a method called request subscription. what it does is basically it subscribes to the web push notifications, and in order to receive the permission, we need to send a public key. This is called a WAP ID. So WAP ID basically means voluntary application server identification. So this is a cryptographic key, which is a public key that has been generated by making use of the web push library. So it's a node-based library. So using the web push generate WAP ID, I have created a JSON, and this is the file which consists of our public key. So this public key I am used for identifying the server, and we will be passing this to the server request. Once we register to this push service, what will happen is we will get a push subscription, and we will be able to subscribe to this as we saw earlier. Now the same thing we can do by making use of the push service dot messages also. So once you subscribe to the messages, we will be receiving the payload of the messages. Similarly, we have the notification clicks, that is when the user clicks on the notification. The push service dot subscription is another observable which will be triggered whenever we establish a connection with this particular push subscription. So once we call this request subscription, immediately the control will come here. So now let's run this application and see what are the things. So here I have refreshed the application, and we will come to this portion. I have modified some things in the HTML part, which we will discuss later. So now what happens is, in case we take the console, you can see that initially itself we make use of the request subscription, and once it is successful, we are logging a console called subscribe. So here you can see that subscribe, and once this subscription is successfully done, that is the push subscription has been created, immediately this subscription observable has been triggered. So that is what we see here. So this is the push subscription object, that is sub, we will be receiving here as well. So I have logged it in the console. So this is the structure of the push subscription. It will have an endpoint, it will have the expiration time, and it will have options, which will consist of the application server key, which we are sending here. Earlier we saw that there is an option to send notifications directly for testing. We can send the notifications from here within the service worker tab. So here, if we give the structure of the notification payload and just press push, what will happen is immediately you can see that a notification message has been displayed here, and within our console we can see that whatever notification we pushed, that it is the data of that is available within the notification. So this is the subscription that has been triggered now. Now we have one more subscription, that is the notification clicks. So what it means is that in case I click on this notification, so actually I am navigating to a external website. At the same time, if you go here, you can see that when I clicked on that particular notification, this particular observable has received a new data. So that is the notification body which we are displaying here. So the push notification which we saw currently was how we can do a test push notification from the browser itself. So now let's see how we can do the same from the server. So here I have created a Nest.js server, and within that, here in the main.ts, I have added the web push library, and making use of that, I am setting the WAP ID details. So the WAP ID which we had earlier created using the web push on the client side, I have added the public key and the private key here, and I am setting those details within the web push. And now what I am going to do is, here in the UI I have created a text area where I can enter any notification. Like notification payload has a particular structure that we will take a look into detail. And once we enter the data here, we can press the send notification button. So if you go to the send notification button, this is the property. Like if you see here, once you click the send notification method will be created, and which in turn will call the notification service. And within the notification service, what we are doing is we are basically making a post call to this API notifications. So if you go to the server, you can see that when we click on the notifications, basically before sending notification, we need to create a subscription. So what we are doing is, we previously saw that we are requesting the subscription, and as a result of that, we will be getting a push subscription object. So that push subscription object, we are sending it back to the server. So I am making use of the add subscription API, which is calling the subscription API. And if we go here, you can see that I am pushing that into an array, and I am storing the push subscription temporarily within the server. Now, once I have stored it here, when I click on the notification and I'm sending the notification payload, what we'll be doing is I'll be taking that subscription object and I'll be passing it to the webpush.send notification in order to send the notification back to the client. Now let's see whether our application works. So I am copying the data from within our browser and I am pasting it here. So let's go through the syntax of this notification. So if you look into the structure of the notification payload, this is the syntax. So basically we have a title. So the title here we have given is Angular updates, and let's see where it comes. So here we can see that this is the title part of our notification. Now similarly, we have some other properties like notification options. So here if you go, we have the body. So let's try that. So here I am going to write a body for our notification. I am saying that Angular 13 is released. Now let's see. Here you can see that the body has been displayed in our notification. Now similarly we have another key called actions, which we will take a look after some time. We have another thing called the icon. So let's add that. So here I am going to give an icon which we already have in our Angular application. So when I click on send notification, you can see that an icon is getting displayed here. Similarly, we have another key called image. So you can try that as well. So in image, I am going to give a different size of our image. Let it be 192. So I am giving the 192 PNG. Now you can see that the image is getting displayed in the background here. So similarly, we have multiple options here. And here you can see that there is a key called data. So data is any custom data you need to pass to the notification. So here what I am doing is, there is a key called on action click. So basically what it means is, when the user clicks on the notification, what are the different actions that need to be done. So here we have defined a default action, that is, when you click on the notification, the operation to be done is we need to open a window and we need to navigate to the URL, that is google.com. So when I click on the notification, the action is executed and the google.com application is opened. We have another key called actions. So actions is basically a list in which you can define some custom action. You can give a name for that. That's navigate. Here I am giving it as navigate. And you can give the title, which will be shown as the description of the button. So this action name we will be able to link to any particular action click. So here instead of the default one, I am giving the name as navigate. When I send the notification, you can see that there's a button with the title. When we click on that, particular action is performed. Another action or operation that is available is the focus last focused or open. So here actually I have another instance of the PWA opened here. Now in case I give the path as home, and when I send this notification, when I click the button, you can see that the focus automatically came to the other tab of our PWA. And another option is the navigate last focused or open. So this is similar to the previous one, but the thing is that instead of focusing, it actually navigates to that particular URL. Now let's take a look at another concept that is closely related to the PWA, that is the app shell. So app shell is basically the process of creating an application shell, that is some common area within our UI that will be shared across multiple routes. So suppose we have a header in our application that is being shared across multiple routes. What we need to do is that we will want to render that particular header alone very quickly so that it gives the feeling of a native application. So you would have noticed that even while using the PWA, the first time installation will be somewhat slow because the actual assets needs to be downloaded and cached by the service worker. So by making use of the app shell, what we are doing is we will be doing the server-side rendering of the initial page or the app shell, and we will be sending that HTML and styles back to the browser. So it will be much quicker because we need not actually wait for the JavaScript to download. So now let's see how we can add the app shell to our application. That's the PWA. We can make use of the ng generate app shell command. So the app shell has been added to our application. Let's see the changes. If we go to the Angular JSON, you can see that it has added the configuration for the browser. So basically now we are doing the server-side rendering as well. So there will be two folders within our disk. The UI will be the browser and the server-side rendered output will be there in the server folder. So the server related build steps have been added here. Similarly, we have another step called the app shell, and here we are saying that the option, that's the root shell, should be server-side rendered, and basically we will be doing something similar to the pre-rendering. Basically during the build phase itself, page will be created in the dist folder. The target, you can see that it includes both the browser target as well as the server target. Now if we go to the package JSON, they have added the platform server, which is needed for server-side rendering. They added the tsconfig server that is needed by the SSR. Again, we have a main.server.ts, which is similar to the SSR video which I have already done. So in case you have not seen it, please give it a look. All these steps are similar to whatever we encountered in the SSR. And here only difference between the SSR and app shell is that an app shell component has been created and it has been included in the declarations. Now if you go to the app shell, this is just a simple component with this template. In the component there is nothing much. And now since in our application we do not have any common material to be shared between both these roots, what I am doing is I am removing this app shell because actually don't need it. But in an ideal PWA which makes use of a common template, you should make use of the app shell. So here in the app server module as well, since I removed the app shell component, I am removing all the references to that, and even I don't need a root because I don't have a common thing. So once I have done this, what I'll do is I'll go to the Angular JSON, and here we can go to the app shell target. So in order to run that, in order to build the application, we can do this command ng run pwa sample colon, that's the name of the project, and we need to identify the target, that is app shell production. So our app shell has been built completely. Now we can serve the HTTP server, but we need to serve the contents of the browser folder within the PWA sample. So once we do that, when we refresh the application, you can see that if you go to the network tab, so this is the latest version. Now if you go to the localhost, here you can see that our initial page, that is index.html, is actually server-side rendered, and even before the JavaScript is loaded, this is available. So our initial load of the PWA also will be faster. Let's see how we can uninstall a PWA. So if you go here, you have the option uninstall PWA sample. Click on that. We will be able to uninstall. If you want to clear the data from there, we can give that option. Now if you come here, you can see that the PWA has been removed. So hope you are able to get a good understanding about how to create a progressive web app by making use of Angular. See you soon. Thank you.